All right, welcome everybody. Brian McLogan with a live stream for our next assignment, which we're going to be dealing with in analytic geometry, also known as conic section. So in this live stream, we are going to take place here of the parabola. Basically what we're going to do is look into determining the focus, the vertex, and the directrix for parabolas that are going to be opening horizontally as well as vertically. So we'll work through a couple of those problems in standard as well as general form. We'll work at looking into writing the equation of a conic section or of the parabola when given certain pieces of information. And then we'll work on some multiple choice. So had a little issues last time here with my live stream, but I think I didn't really do anything else. I just kind of checked my internet here. So it looks like we are good to go. So CKB said we moved to ellipses and parabolas. Well, guess what? I am planning on doing another one on the ellipse since I missed yesterday. I was planning on doing yesterday as well as tonight. So since last night I had that issue, I am going to try to double it up here. But what I'll do is I'm going to do this live stream first, take like a 30-minute break, and then come back on. So to do that, though, I am going to try to condense these a little bit quicker. So I'll try to get to maybe some questions I have for you guys before, but I don't want to spend too much time kind of chatting away. Therefore, I can just kind of do these, make sure I can fit, two live streams in here as well. So I see Echo and All Jokes, you guys on there. So very happy for you guys to join. Let's go ahead and get right started into this little live, or get onto this work. So therefore, we can get through it. As always, guys, if you have questions throughout the live stream on anything that I am covering, please make sure you guys add them in the chat. What I will do is after we kind of hit the halfway point, what I'll do is I'll go back and check check any questions, see if there's anything I can maybe elaborate on, or make any corrections. And then what I'll do is I'll kind of work through the multiple choice. And obviously, if there's any questions, we have a little bit extra time after that, then I'll be more than happy to answer your guys' questions. So it looks like the live stream health is going good. So as long as there's not a bad buffer or delay, I think I'm going pretty good. I'm just going to go ahead and get started. Standard form and completing the square. Yes, KB, I will be doing, I think, 2 problems, or just maybe 1 problem with completing the square. I think there's only 1. Yeah, I only have 1 in this homework, and I think next homework I have another homework one as well. So, all right, let's go ahead and get started. So I didn't add to, I forgot to plug in my thing. So hold on a second. This might take a second for that to pop up. So I tried to do in these live streams, just to let you guys know a little bit of timing as I kind of wait for my tablet pen to work. So I'll be doing parabola and ellipse tonight. I'll probably be looking into doing the hyperbola then on Sunday. Going through that homework, and therefore we'll also do a quiz, which I'll plan on doing on that Tuesday. So therefore, hopefully that will give you guys, quiz is actually not going to be till Wednesday. So just so you guys get an update of the live streams, will be quite a bit as we round out this year. And then once I'm done with going through the curriculum, we'll get into some studying for the final exam. So for those of you that are hopefully taking a final exam in May or early June, we'll have some videos for you. So hello, Fernando. Let's go ahead and get started. All right, so in the first one, guys, we have y squared equals negative 16, and there's supposed to be an x here. I'm not sure what I did. There we go. So on these first one, I mixed up here. So that's supposed to be an x, and that was supposed to be a y. Okay, so I'm not going to go through the forms. That's obviously what we did in our notes here. The main important thing, guys, is to identify the directrix, LU, and graph. Okay, so the first thing we want to do is, kind of identify the vertex. And the vertex is going to be your HK. And obviously, if we are shifting the graph at all, that's going to shift where the vertex is. But if there's no shifting, meaning like the H and the K, then we're going to have a vertex at 0, 0. So in this case, we can see that our vertex is at 0, 0. So I'm just going to go ahead and graph this. And I'll just put a nice little V here to represent the vertex. The next thing I notice here is that the y is squared. So that means the parabola either opens up to the left or it opens up to the right. Because obviously if the x was squared it would kind of be like a quadratic function, right? Opening up, opening down, something that we're familiar with when we studied quadratic functions. Now, to determine if it opens left or right is by looking at the value of p. So remember the equation, the coefficient of your linear term here, which is negative 16, is equal to 4p. So we can say negative 16 is equal to 4p, and therefore divided by 4 on both sides, 4 equals p equals a negative 4. So what that means is the distance from the vertex to the focus is going to be 4 units to the left. This is a distance and direction. 2, 3, 4. All right, so therefore that is going to be where your focus is, which is at negative 4, comma 0. All right? So what that means is since your parabola always opens up towards your focus, so therefore I don't need to graph this over here. I know that my parabola is going to open up to the left. The important thing about this value of p is that tells you where from the vertex to your focus, where it goes, but also you know in the opposite direction is going to be your directrix. So that's going to be 1, 2, 3, 4 units to the right. And that is going to be a vertical line, which is perpendicular to the axis of symmetry of the parabola. So we'll just say directrix, and that will be x is equal to 4. And there you go. That's basically all we need to do in that case. All right, so now let's go and look at one here, or in this format where you can see there is some transformations. And remember, the transformations here for the parabola would be 4p times, y minus k. K is always with y, h is always with x. And this one is just y squared equals 4p times x. So just so you guys kind of get an idea here of the transformations, what's going on. So the h and the k here is going to basically be our new vertex. Or actually our vertex, which will be hk. So in this case, we can see the vertex. Now again, remember it's x minus h. So therefore it's x minus 2, h is equal to 2. So if you want to put them in parentheses to better understand it, you can do that. But you can see that my vertex is going to be 2, and then this would be x minus a negative 3. So therefore y minus a negative 3 is the same thing as y plus 3. So therefore you can see it's those opposite signs, that x opposite of h, y opposite of k. Another way you guys can kind of think about that just to make sure that that's opposite side. So now let's go ahead and graph the vertex here, or graph the parabola with the vertex. So that's going to be at 1, 2, negative 3, 1, 2, 3. Put a little v here. All right, now in this case we see that x is squared. So the parabola either opens up or it's open down. To determine if it is, we got to determine what is p. So you can see our coefficient here of our linear term is 4. So we just say 4p is equal to 4, therefore p is equal to 1. Since p is positive in this case, it's going to be going up 1. So there is your focus, and again, our parabola always opens up towards our focus, so it would look something like this. Not really like that, but kind of close to that. And then just remember our directrix is going to be the opposite of p, so in the opposite direction, so that'd be 1 unit down. And that's, in this case, is going to be a horizontal line. So from here, I can just say that my focus is 1 unit up, so that's going to be 2, negative 2. And my directrix is going to be a horizontal line at y is equal to negative 4. All right. So there's basically 2 when we have them in what we call our standard form. Now, this third example is also in standard form, but we have a fraction, which should not scare you, but it is something that we want to make sure that we are prepared for. So this one only has one term is being subtracted. And you can see that's going to be the x. So that is going to be a transformation horizontally, since we're not subtracting anything from the y. We also see that the y is squared, so we know that the parabola is going to be opening up to the right to the right or to the left, just kind of like our first example. So first thing is let's go ahead and identify the vertex here. So the vertex doesn't look like it's going to be very fun to graph, but again, we're just going to plot this, right? So this is going to be at 1/4, 0. So if we're just going to go ahead and graph that, let's make this 1, right? And so 1/4, 0 would be right there, okay? We'll make this a nice little vertex there. Now we need to figure out our p. Well, again, our p is going to be that coefficient. The 4p is going to equal to 3. So we're just going to write an equation. So we're going to say 4p is equal to 3. divide by 4, divide by 4. P is equal to 3/4. All right. So again, we notice though that P is positive, and if you look at that first example, when P was negative, we moved to the left when y was squared. So now when P is positive, that means we're going to be moving to the right. So if you take 1/4, add 3/4 to it, that's actually going to give you 1. That's not that bad. So there's your focus. And we can see that this parabola is going to open up to the right. Now, again, to find the directrix, actually, let's write in the focus here. So the focus is going to be 1, 0. Now the directrix, remember, is in the opposite direction. So if I added 3/4 to the right to get to my focus, I'm going to have to subtract 3/4. So therefore I'm minusing 3/4, and that's going to take me to a -1/2. And that's going to be a vertical line. So my directrix is going to be x is equal to a -1/2. And again, if you just want to do the math, 1/4 minus 3/4 equals -2/4, which equals -1/2. Okay. And there you go. So you can deal with something on the fraction portion. All right. Finally, comes down to the most difficult one that students have struggled with in this chapter is the completing the square. So we've been doing a completing the square for each and every section. We're doing the hyperbolas next, but every single day we're doing completing the square. And, some students are getting the hang of it, and some students still, are kind of struggling with it. And the best advice I can give to anybody that's struggling with it, it is a process. It is a little bit abstract of, sometimes understanding why you're doing certain things. But again, like that really just going through the motions, going through this operations is going to help you not only understand the process, but also to make sure that you don't make little mistakes as you're going through it. So our goal for completing the square, this is what we call general form. And we want our equation to be in one of these two forms, which we call standard form. So to do that, we got to create binomial squared. And the process of creating a binomial squared is completing the square. What you're doing completing the square is you're creating a perfect square trinomial that can be factored to a binomial squared. So notice on both standard forms, the x's and the y's are on opposite sides. So what I'm going to do is I'm going to isolate the terms that I can complete the square with, which in this case is going to be my x squared minus my 4x. Everything else, I'm just going to get to the other side because I want to complete the square with my, that should be a plus. So if I add a 12y to the other side, I'd get a 12y minus 16. Okay, so now what I need to do is I want to create a perfect square trinomial. So if you remember, to create a perfect square trinomial, what we're going to need to do is take b divided by 2 and square it. So in this case, I'm going to take -4 divided by 2 and square it. So -4 divided by 2 is going to equal -4 divided by 2 is -2. -2 squared is equal to 4. Now I'm going to add this term inside those parentheses. That is going to create my perfect square trinomial. But remember, we just can't add something to one side without adding it to the other side, right? We got to make sure we keep this equation equivalent. So this would be 12y minus 16 plus 4. Okay, so now again, the whole idea of this is a perfect square trinomial which can be factored down to a binomial squared. So now we have exactly what we were looking for, a binomial squared. On the right hand side, we've got to do a little bit of math here. This becomes a -12. This is not in your standard form. If you look at that standard form over here, it's 4p times y minus x, right? So we need to make sure that our y coordinate our y variable has a coefficient of 1 inside those parentheses. Right now it has a coefficient of 12. So I need to do one more step here. I need to factor out the 12. And now you can see that my vertex is going to be at 2, 1, not at 2, 12, which is a very common mistake students will make. To understand my graph here, let's go ahead and find our p. So 4p is still going to equal 12. Therefore, divide by 4 on both sides. P is going to equal 3. I notice that my x is squared, so therefore my parabola either opens up or it opens down. So since p is positive, it's going to go up 3 units. So let's just go ahead and graph this here. So I have 1, 2, up 1. P is 3, so that's going to move it up 3 units. And let's see, that's going to be 2, 1, 2, 3, 4. So my focus, I'll put that over here, is going to be 3 units up from there, so that'd be 2, 4. And my directrix is going to be 3 units down from there, which would be a horizontal line. So 1, 2, 3, and that would be x is equal to -2. Okay, so there you go, ladies and gentlemen. That is basically the process for go ahead and determining the focus, the vertex, and the directrix from the graph. The main important thing is, identifying, I think, the vertex first, plotting the vertex, identifying the opening, determine the value p, so therefore you can find the focus and then the directrix. And that's basically fit the width. That's what I was looking for. Perfect. Okay. So now let's go and look into writing the equation. Now, when I'm writing the equation, I'm just going to work on standard form for you. And then what I'll do is I'll take a quick little break and check in with you guys that are having some questions or saying. Again, for those of you that weren't maybe at the beginning of the stream, I'll try to do my best. I'm trying to do a double dip here on the live stream so I can cover both homework sections. So I'll kind of let you guys know how that goes. We'll kind of see how long this takes. So right now we're looking pretty good for time. Let's try to see if we can continue that. All right, so the next one says, given the following information, write the equation of the parabola. And again, we're going to do writing the equation of the parabola in standard form, which is the forms that I had written. These forms up here, these two forms. Okay. So the main idea here is to plot the information you're given, all right, and then from that information determine the value of p as well as the vertex, or I'm sorry, as well as your vertex hk. Well, this one's nice. They give you the vertex hk, 0, 0. I like that. So let's go ahead and plot that. And then let's plot the focus -2, 0. So -2, 0. So here's your focus, here's your vertex, there's your focus. Remember, guys, that the parabola always opens up towards your focus, right? So we know that this parabola has to open up to the left. And if it opens up to the left, that means that y has to be squared, right? So now we know my y is squared. Well, I know my h and my k are 0, so I don't need to subtract it by anything. And since the distance and direction from my vertex to my focus is -p, right? It's going to the left, so p is equal to -2. So I'll just write my equation as y squared equals 4 times p, which is -2, since it's going to the left, times x. And then I can simplify that one more time to -8x. All right, let's go ahead and do another one. So this next one, we have a vertex at 3, -1. So we plot the point, 1, 2, 3, -1. We have a directrix at y equals 2. So that's a nice little horizontal line. Now again, guys, remember that the parabola opens up away from the vertex, right? And the axis of symmetry of the parabola is always perpendicular to the directrix. So therefore, we can determine that our parabola is going to open up downwards. Since it opens up downwards, I know that I am dealing with a parabola that's going to have x squared. So since I have this vertex, this is my h and this is my k, I can write this as x minus 3 squared, right? Because it's x minus h, so it's x minus 3 squared, because that's my square terms, equals 4p. I don't know 4p yet, and then this would be y minus -1. I'll simplify that later. I just wanted you guys to see why it becomes plus. Now, remember that the distance from the vertex to the directrix is opposite of p. So since we're going up, that's positive, right? Vertex to directrix is distance and direction. So that's, what is that, -1? Yeah. So that's going to be 1, 2, 3. So opposite of p is equal to a positive 3. That means p is equal to a -3. And again, p represents the distance and direction from the vertex to the focus. So therefore, if I just replace p with a -3 and simplify this, I get x minus 3 squared is equal to a 4 times -3 times y plus 1. And therefore, I can settle that down into an x minus 3 squared equals a -12 times y plus 1. All right, so last but not least, guys, and then we'll go ahead and take a break here. So in this example, I have the focus, which is 0, 1, and my directrix x equals -1. So I'll go ahead and plot the point here. And my directrix x equals -1. Okay, there's my focus. All right, so we got to kind of understand something that's important here about the focus and the directrix. We have the focus, we have the directrix. Now we need to kind of understand, well, where does the vertex, where does the vertex come in? So remember, the vertex is actually right in between your vertex and your directrix. It's in the middle. So we know that here's going to be my vertex. And then obviously we know that the parabola always opens up towards its focus. So we see the distance from the vertex to the focus is 1, and since it's going up, it's going to be positive. So p is equal to 1. We can see the vertex is 0, 0, and since the parabola opens up, we know that we're going to have our variable x is going to be squared. So I can go ahead and write the equation here rather quickly. Just write this as x squared equals 4y, or it's really 4 times 1, which will just be 4y. But just for the sake of time purposes, I'm going to try to keep that down for you. All right, so before I go ahead and get to the multiple choice, if any of you guys want to go ahead and take a look at these first two problems, go ahead and check it in. I'll go ahead and see. Luca does not seem like he is very happy to be here, but that is okay. I am sorry about that, but okay. Samuel, for example, wouldn't the directions be y equals -2? Thank you for checking into for example number 4. I don't know. Okay, here's example number 4. Y equals -2. Yeah. Oh, good catch. Yes, thank you, Sam. I wrote in the x, but that is definitely a y. Thank you, Sam, for keeping me honest. All right. Victory, Sam, thank you. Tyrone, TNG, I respect you do the videos. Good job, nothing else. Happy to very help you out, Jose. All right, Desiree, you have a question. I'll try to see what I can do for you. I'm going to come back to these, though, at the end, just because I want to make sure I get through some of these questions, and then I'll see if I have any time for you. So, Abraham, Fernando, Vasila, thank you, Kitty. Happy to very help you. Chris, good to see you. Awesome. Thank you so much. You are very welcome, Jack. All right, let's go ahead and wrap this up, guys. And then what I'll do is when I do, I'll plan on probably going live here. I'll probably take like a half an hour, 45-minute break, and then I'll go live again. If you guys have any questions then I'll be able to answer them. And if you guys don't want to wait around or check my other live stream, you can always check on the replay. Do you have any videos on rational addition expressions? Kathy, yes, I would search my channel, look at rational expressions, adding rational expressions. I have a lot of videos, unfortunately and fortunately. So yeah, but I would definitely just check those out. I definitely should have something for you. But Desiree, since you added your question, I will try to do my best to get to that. So let's go and see what we can do here. So multiple choice. Let's do these in red. So this one says find the vertex focus of the parabola. So I noticed that this is going to be my 4p. So I'm going to say 4p is equal to a -9/8. Divide by 4. Divide by 4. Remember that dividing by 4 is the same thing as multiplying by a fraction. So therefore, p is equal to a -9/32. And obviously that's going to be distance from your vertex to your focus here. And my vertex is at 0, 0. So therefore, I would be shifting it to the left, right, which is your y coordinate. And so you can see that D is my answer. Nothing else here has that. So they're just computing it not with the 4p. So you just want to be careful with that one. So yes, you definitely have to include that 4p there. The next one says find the equation of the parabola with the vertex at 5, 4 and focus -3, 4. So let's go ahead and plot this information to understand it. So we have a vertex at 5, 2, 3, 4, 5, 1, 2, 3, 4. There's my vertex, and a focus at -3, 1, 2, 3, 4. Okay, so again, just remember, guys, that the parabola always opens up towards its focus. Since the distance from my vertex to my focus here is going to be 8, but since you're going to the left from vertex to focus, I know that my p is equal to a -8. Again, my vertex, this is my h and my k, so therefore 4p would equal -32. So that's not it, that's not it, and that's not it. So it's these two. My h, which is always connected with my x, is going to be 5. So that should be x minus 5, good. And then my k should be y minus 4, and this one's y plus 4. So therefore, that's going to be your answer, not this one, because that plus. So that plus messes everything up. All right, number 3 here. So number 3 has y minus 7 squared equals 4 times x minus 3. So hopefully we see the x minus 3, y minus 3, so we know the vertex is going to be 3 comma 7. So that doesn't work, and that doesn't work. The next thing is we can see that p is going to be equal to, 4p is equal to 4. So p is equal to 1. And since my y is squared, that means my parabola opens up horizontally to the left or to the right. Since p is positive, that means it's going to open up to the right. So therefore, my focus is to the right of 3, 7 would be 4 comma 7. And you can see that that would be my answer, A, in this case. All right, last but not least here, guys, number 10, focus at 0, comma, negative 5, directrix y equals 5. So again, let's go ahead and plot this. So we have 0, negative 5. So 1, 2, 3, 4, 5. And then my directrix is at y equals 5. 1, 2, 3, 4, 5. There's my focus. So again, guys, remember with the focus and the directrix, your vertex is right in the middle, right? And then also your parabolas always open up towards your focus, okay? So now since it's opening up towards my focus, we know that x has to be squared, right? So anything that has the y squared is not going to work. Okay, so it's one of these two. Now, the important thing here is remember the equation is x squared equals, so it's at the vertex, is 4p y. That is our standard form here, right? So, or we could also write this as 1 over 4p x squared equals y. All right? So it's important that either one of those forms could work. Now, we've really only talked about this as the form in my class, but all you got to do is divide by 4p and you get it in this form, right? So, I mean, it's not really any much of a difference. We notice that p is going to equal 1, 2, 3, 4, 5, and it's in the negative direction. So p is equal to a negative 5. That means 4p then is equal to a negative 20. And you can see here, A is going to be your answer. There you go. Because I like turtles. So there you go, ladies and gentlemen. That is your conic sections for the parabola. Hopefully that has helped you guys out. If you have any questions on anything that I did, please make sure you guys go through chat. I always try to go through the chat one last time after I've finished. And if there's any kind of follow-up questions on this content, then I always try to answer them to the best of my ability. And then, obviously, if I have some questions, which I'll try to do my best here, see if I can maybe add a couple questions for some of you guys in there. M. Rizal says, what is this class taught? And I'm teaching this for my pre-calculus class. They've been doing videos on, or we're starting the conic sections unit. Jack says, can you do some logarithmic equations? Sure, if you can give me a logarithmic equations. Hey, Kitty. Gamer, hopefully the stream looks good for you. So I don't know what was going on last night, but everything seems to be looking good on my end. So let me know what you think. And let's see. Wade says, love your videos. Well, thank you very much. So happy to help. All right. Desiree did ask a question. Let me see if I can figure this out. Having trouble on a test. I have a problem that says write an equation for the hyperbola that satisfies the set of conditions. Okay, so Desiree has something on hyperbolas, which we haven't talked about in my class yet, but let's do that. So you have vertices, 9, -3, and -5, -3. And your foci is going to be 2 square root 2 square root plus or minus 53. 2 square root plus or minus, is that the square root of 2 plus or minus 53? So the square root of 2 plus or minus 53, comma -3, minus 53. Oh, plus or minus. So, hold on. Yeah, I was like, that doesn't make sense. So, let's do. So, this would be 53 minus square root of 2, comma -3. So, therefore, you got to be able to figure out what that is going to be. So that's, I'm not understanding, Desiree. Sorry, I'm just not understanding exactly obviously from your vertices, you can go ahead and figure out, like if you plot this, a couple things for you to know here. So we have 9, -3. So 1, 2, 3, 4, 5, 6, 7, 8, 9, -3. 1, 2, 3. There's one vertice. The other vertice is -5. 1, 2, 3, 4, 5, and then -3. All right. So the nice thing here is we can see that from here we can find the midpoint, right? So that's going to be 7 units away. So 1, 2, 3, 4, 5, 6, 7. And that should be 1, 2, 3, 4, 5, 6, 7. Right. So therefore we can see the center is at 2, -3. We can also see that the transverse axis is going to be horizontal. So therefore the equation that you're going to be using is going to be y minus 2 squared all over a squared. All right, let's just do k here for you. Yeah. Y minus k squared minus x minus h squared over b squared equals 1. We know that the distance from the center to your vertices is a, which is 7. So a is equal to 7. So that means a squared is equal to 49. I'm just trying to figure out what you wrote in there for the c, but obviously the foci. Obviously this distance here from -3, that is going to be your c value, but I'm just not understanding what you wrote and how to get to that. And then obviously once you have c, remember that a squared plus b squared is equal to c squared. So you plug in your value for c, you plug in value a, and then go ahead and solve for b. And that's basically your equation. But to help you out real quick with this, that would be 49 minus x minus 2. Oops, I'm sorry. That's going to be x, that's plus 3. X minus 2 over b squared. Now, I'm just not sure of that. But anyways, guys, as I mentioned, if you're just kind of getting into the stream and you have some questions, I apologize. I'm not going to get to them on this stream. But what I definitely will do is I will look into probably picking it back up in about like 30, 45 minutes. I'll come back and we'll cover the ellipse. And if you guys have some additional questions, you guys can definitely send them over to me and I'll do my best to answer them. So you should be experiencing this now. Very good. All right, guys. Well, very good. Can you hear from the bottom right? The first written says why was he not? Yep, we got that one. Log. Jack, I'm not sure. Yeah, you asked me to do some logarithm equations. I'm not sure what you want me to do with that equation. So hopefully, Jack, if you'll be on the next stream, you can maybe give me a little bit more direction. I'm not sure what I was supposed to do for that equation. But either way, guys, I'm going to sign off early on this one. But for those of you that are interested, you want to join on the next live stream, I'll be back here in about 45 minutes. So you're going to have to keep the notifications on. I'm not sure when exactly I'll be on, but probably be about 30 to 45 minutes. Look for notifications because I will be letting you know. All right. Cheers. No, stop.